facing he sees in this industry. Any questions about competitions, any of those things? Tomorrow we're going to go over more details of the global data competition as well as the OC Canada competition. So if you haven't heard of any of those yet, pay attention. We'll get a lot of stuff out there relatively soon.
You can always come see us afterwards too, and we'll be happy to talk all about it.
Is the Taylor Swift stuff old news by now? I didn't. Okay.
It's not old news, but it wrapped up last week.
Yeah.
Saturday, so the teams were trying to predict on 0.3 of a second clips, audio clips, on whether or not her hits were mega hits or less mega. and they were able to predict, I think all top 5 were in the 99th percentile. Jason Bond won with 99.62%.
Wow.
So, and then you had Devin Dietrichson and kind of like that. So, like pretty awesome. Okay.
Hold on.
And then,
No.
does everybody know where the meetup is? And like biggameutah.org?
Meet tomorrow? Like what, how long is tomorrow? Is that gonna go just an hour or?
Normally an hour. Make sure driver's license, everything else. There'll be, they'll go 12 to 1. We tend to leave about 1:30.
Oh, okay. Thanks.
Next time we need to be out by 9 o'clock.
Yeah, that looks better.
So can I hide this thing on the front?
Yes, you can say hi.
So we're broadcasting now?
Yep, we're good.
Okay, well, thanks for coming tonight. Thanks, Nick, for inviting me to come and present. I'm gonna sit down so I don't pace in front of the screen a little bit. Hopefully everybody can see. I'll be a little slideshow, and then I'll show a demo of our product to kind of give you an idea of what's going on here. Again, my name is Andy Lawrence. I'm CTO of a new startup. My partner David Marsh over here. We've got this little extreme technology we've put together and try to get it off the ground. I put a reference to my blog out there. You can feel free to browse to that one. A little bit about my background. I'm a programmer. Worked for a number of companies over the years, writing things like file system drivers for Novell back in the good old DOS, Windows 3.1, and OS2 days. Worked for a little startup. That's where I met Dave, actually, at PowerQuest, writing a disk utilities backup recovery system product called Partition Magic. I don't know if any of you remember heard of that one. And so I've worked for a number of companies on a variety of projects, but my area of expertise is mainly in data management, specifically file systems and disk utility kinds of things. And so I have invented, designed, and partially implemented a brand new, revolutionary new data management system. We are.
I lost your PowerPoint for some reason.
Okay.
See if you can. I think it closed.
They're close.
Yeah, I don't know why. But let's just up there. Sorry about that.
All right. And then back up.
Technical difficulties. Okay,
So we're calling it the digit management system. Digits are our objects that we create, which is short for a data widget, versatile little data objects that we can do all kinds of fun things with. It's a general purpose data manager. So we're not specific to any particular kind of data, but we want to handle pretty much any kind of persistent data out there. Object-based system. It was originally designed to be a replacement for file systems. Over the years, I've got a long list of things that are wrong with file systems, and I was going to fix them with a new system. So it was originally designed to mainly handle unstructured data, treat everything like a bag of bits, but I needed a certain amount of structured data. I wanted to very much enhance the metadata set that we could attach to things like photos and documents and other things. And the structured data turned out to work so well that I found that I think we can expand quite a bit our focus here and compete in some database and NoSQL kinds of solutions. So we're kind of targeting this right now as a solution to what I call the silo problem. We have lots of data silos out there. So let's discuss some of those silos. We have data managers that have been around for a long time, and some that are a little newer. I'm calling these primary. We have a lot of secondary kinds of data managers, things like iTunes that manages your music, or Picasa that helps you manage your photos. But all those secondary generally sit on top of a primary. They store their data either in the file system or a database. So I'm mainly talking about the primary things here. File systems that have been around for more than 50 years. There's really been, more than 100 different file systems created over that time frame. If you took the top dozen or so, they're probably would account to 99 point something percent of all the installed systems right now. But still, you got a dozen different file systems that are fairly popular. Then along came relational database management systems, because of course file systems didn't handle structured data very well. And for decades, we've had these relational databases, from Oracle and MySQL and SQL Server, etc. In the last 10 or 15 years, a number of sort of new types of data managers have emerged on the market, mainly the NoSQL, which are basically 4 different categories. You have your document stores, things like MongoDB, your key value stores, like RAC, your column families, graph databases. So there's some different models that fit into that NoSQL world. And of course, you have your cloud storage is coming on strong with Amazon S3 and OpenStack, their Swift stuff, and there's a distributed file system. I understand some people here are familiar with HDFS, the whole Hadoop world, and so as each one of these came along, and I could list off a whole alphabet of soup of products and companies that have entered into each one of these categories. Now, why are there so many of these things? Generally, it's because what was existing didn't meet a specific need. The relational databases were great when you had banking kinds of stuff, and when web traffic came along and they wanted to push 1,000 documents in a microsecond, that it didn't fit that model very well. The very rigid schema didn't account for fast changes in what you wanted to store, things like that. So and definitely speed characteristics played a big role, and sometimes there's special requirements. You need ACID requirements or not in your database. If you don't, then you can loosen those up a bit. So we've had this sort of proliferation of data managers out there, but that presents kind of a problem. Each system comes with its own little silo of information. And each one has its own API. Generally, when a new data management system comes along, and there's 3 or 4 players, they have their own unique API. And as they get a little more popular, standards committees and companies go, I don't want to have to write an entire different program every time I want to switch between MySQL and Postgres, or between Amazon S3 or OpenStack. And so you generally get some coalescing around a common API, whether that be POSIX standards, SQL, or RESTful interfaces. But they all have a different data model. So with file system, it's just hierarchical tree of files. In the relational world, you have tables and indexes and things like that. each system has its own set of management functions, even though they're common categories, like backup, for example, but you back up a file system differently than you back up your database, or if you're backing up a NoSQL kind of thing, it's a different mechanisms. All their internal structures are very much different. And supported utilities. When Hadoop came out, of course, there was some quick adoption because it did something very, very fast, big data. But then as more people came in, go, wait a minute, in my Oracle environment, I could do this, and now I can't do that with Hadoop. So of course, everyone, a little vacuum there, everyone tries to fill those needs. And I looked on the Apache website a week or so ago, and boy, talk about explosion of projects, trying to get, query languages and backup and snapshotting and all these kinds of different things that people have missed from their other data managers, they want to apply to the new one. So, but these different silos present a number of problems, You've written programs that go discover data in a file system, and suddenly your data's in a whole different environment, and your programmers aren't familiar maybe with that, or things you used to be able to do just don't quite fit in the new model. So data discovery can be a problem. For example, you go on Amazon S3 and create a bucket and throw 500 million objects into that thing. I'm not sure what the limit is on a bucket these days, but there's just a big key value store, and you fill it up with stuff. But then if you want to go find stuff out there, data discovery is a problem. And frankly, file systems have this problem for quite a while. Meaning, file systems were designed back in the days when if you had 100 files in your volume, your disk was full. So finding, that needle in a haystack wasn't a big priority when they designed the data model for file systems. And these days, you put a couple 100,000 files in a file system, it starts getting a little slower and slower. By the time you get into the millions, go to lunch while your query runs, because it can take a while. Another problem is, data. Even though we have little pieces of data, generally data doesn't reside on its own. There's dependencies. There's sets of data. So you can't just copy one file. You need to copy all the pieces you need. And discovering where those are and how many you need, those kinds of are problems. Movement of data between systems. Even if you're just moving from your database from MySQL to Postgres, they're the same kind of data manager, right? But and they're mostly the same, so it shouldn't be a Herculean task to move your data, but there's still all those little gotchas that kind of get you. Synchronization between, if you've got a bunch of these, even if they're the same data manager, you got 10 instances of a file system running around, and you want to synchronize data between your volumes, that can be a problem. Metadata, your forms of metadata are different, so in the file system world, they said, oh, we need more rich metadata, so they came up with extended attributes. I don't know if any of you actually used extended attributes, but they're kind of a pain. They're off by default. They're not really searchable. There's no schema to them, so anybody can just come up with their own key value mechanisms, and makes it kind of hard. If you go looking for an author of a document, for example, you don't know whether to search for author equals somebody, or writer equals somebody, or publisher equals somebody. And so it can be kind of a pain to find what you're looking for. And the last thing is sort of this least common denominator problem. So as each system tries to differentiate itself, whether it be in the database world or the NoSQL world, or in the distributed systems, everybody goes, oh, I want to do something far better than my competition. So they put together a feature But, and then, you know, a programmer on the company goes, oh, I want to really use that feature. But his boss goes, no, we don't want to use that because if we want to migrate over to the competition, they don't have that feature. So they tend to program to the very least common denominator. And that's really one of the reasons why extended attributes never really caught on in file systems, is because nobody wanted to write a program that only worked on NTFS or only worked on, you know, ext2 but not ext3 or vice versa, you know. So it became very hard to sort of bring new features to market. So as I said, I originally designed this system to be a file system replacement. So I didn't want this to be just another silo where, you know, you got 50 silos already and now you have 51. I wanted to actually replace a lot of things, the file systems. But that's no small task, obviously, because file systems are ubiquitous. They've been around for a long time. There's tons of legacy code. So I knew going into this that the bar to adoption was going to be very high, meaning I couldn't build a system that was just 10% faster or 5% easier to use in some area. I knew that this new system had to be at least twice as good as the thing I was replacing, because, you know, nobody's going to really adopt. You can get niche players that really care about, oh, I'm going to squeeze that extra 3% out of this. But to get wide adoption where, you know, 15 years from now, somebody will say, what's a file system? I don't even know what that is because it's been completely replaced. You got to be a lot better than what it is. And in order to do that, I figured out that I had to break the data model of the file system to do that. I couldn't build just another file system adhering to the decades-old architecture and get the performance and features that I wanted. So this new system that I built has to solve problems, but it also has to add some new capabilities in order to reach that 2 times minimum threshold. And I think I've exceeded that quite a bit, but I'll leave that up to you guys to figure that out. But file systems have a number of problems that they've you know, I'm sure none of you have ever encountered these, but there's, you know, naming conflict. Somebody overwrites your file just because it has the same name, or what was called the DLL hell. I'm sure some of you have run into that, where somebody just copied it. It didn't overwrite your file, but it just happened to be earlier in your search path, and so it grabbed an older version or a newer version of the DLL, and the program started behaving very weird, and you had to get out some system tools to figure out even what DLL got loaded to figure out what's going on. With files, the name is the unique identifier, and it's not just the name, but it's the full path. So somebody comes along and changes a folder name in your path, and suddenly your unique identifier changed. So anybody that has stored the full path to your file in a database or in a file, suddenly that reference is no longer valid. There's very limited classifications. So for example, inodes. There's nothing in an inode that says this file you just created is a photo. There's just nothing in there. Can't tell a document from a video, from a you know, script. So there was just really nothing in there. Another thing that the file systems don't do, it can't tell you the difference between your data, meaning stuff you actually created, and stuff you got somewhere else. So, you know, I want to go find my music versus what Microsoft installed on my computer. There's no way to tell that. So I wanted to have a classification system where I could actually say, this is something I created on this box versus something I downloaded off the internet or the operating system installed for me. Slow search, again, scaling problems. And Microsoft and Apple realized this was a problem a while back, and they created Spotlight on the Mac, Windows Search on Windows. You've got, you know, various third parties that have created in Linux, you know, various databases to do a background metadata scan of your system and index everything. So now you can just type in keywords and up pops your results, right? Well, that works sometimes. One problem is it takes sometimes hours to go through your entire metadata and index everything. Now you've got two sets of metadata, the real metadata and the stuff in the index, and those things can come out of sync very easily. You boot into a new operating system, or you happen to have one of these things, a portable drive, you've indexed it, and then you plug it into a different computer, suddenly your index is no longer valid. And so, whether it's in trying to group things together, again, application to put anything anywhere in the tree. So just because you have a folder called, My Documents, doesn't mean the only thing in there is your documents and that all your documents are in there. In fact, it's highly unlikely that that's going to happen. With security model and tagging, be able to tag your data. These are all problems that my system was designed to try to tackle. So to give you a kind of real world example, let's take this portable hard drive right here. I bought it at Costco about a year ago. This one holds 2 terabytes of capacity. It cost me like $89. So this is my shirt pocket. Might be a little aggressive to say I could put 10 million files on this thing before it's full. That'd be an average of about 200K per file. Hard to say. Let's say I'm a professional photographer, and I've got 10 million